Part 3. You will hear two biology students comparing their research on evidence of life on Earth and other planets. First, you have some time to look at questions 21 to 25. Now listen carefully and answer questions 21 to 25.
Hi, Katrina.
Hey, Simon. Are you ready to compare notes for our presentation?
Yes, I think so. I found some really good sources describing how we find evidence of living things here and on other planets.
Me too.
So let's start with the study of fossils. That's the remains of prehistoric plants and animals now found in rock.
Right. Let's review the different fossil categories first. The different categories are based on how they're formed.
What about impression fossils? They're like a footprint. If you walk along the beach, you leave footprints in the sand which show what your feet look like. In the same way, these fossils give us a good idea of what ancient plants looked like.
Right. Particularly the leaves. But they're completely inorganic, so they don't provide any cells for analysis.
We should probably include cast fossils. They're an interesting category.
Yes. I saw a cast of an ancient tree once in a museum and it was amazing.
Yes. What distinguishes them from two-dimensional fossils is that they're like a three-dimensional model of what the plant would have looked like.
Right. The plant tissue dies and leaves a hole which is filled by soft soil.
And that eventually hardens to make the cast, which retains the shape of the original.
Now, we definitely need to include permineralization fossils. They offer so much detailed information about ancient plants to scientists.
Yes, right down to a cellular level, which isn't possible with other fossils. Does this mean they were formed in special conditions?
No, quite common conditions, I think. They're formed when the plant is flooded with a fluid that's rich in minerals. This preserves them.
Okay. What about compaction fossils?
They're very common amongst plant fossils, but it's very rare to find an animal preserved in this way.
Oh, I didn't know that. I do know that they're usually found in swamps and other muddy areas.
We should probably include fusane fossils.
They weren't on my list. What are they?
They're the remains of a plant after it's been burned. They're often small and light, so they can drift in rivers or seas for quite long distances and provide evidence of life away from those areas where you tend to find the most fossils.
Ah, sounds like an interesting type of fossil.
Before you hear the rest of the discussion, you have some time to look at questions 26 to 30. Now listen and answer questions 26 to 30.
So we've talked about how we find evidence of past life on Earth, and in the second part of our presentation, we want to demonstrate in a practical way how to find out if there has ever been life on other planets in the solar system.
Yes, and I thought we could present the information in the form of a flowchart.
Great idea. So, the procedure begins by sending a spacecraft to land on the planet.
Right. Then a vehicle, called a rover, is sent out from the spacecraft. This is a small machine which travels over the planet. The rover needs to find a good range of organic material, so they direct it to a site that's likely to provide this. Then the rover drills down under the surface to collect a sample.
Why does the sample have to come from underneath? Why not just scoop up some soil from the top? Is it to stop contamination from the rover? I've heard that can be a problem.
No, the rover is clean. It's actually because of the atmosphere. Unlike our planet, the surface might be exposed to high levels of radiation, and that could kill anything living on the surface.
I see. But something could still be present underneath the surface.
Yes, it's possible.
So at this point, the soil and rocks that have been collected would need to be analysed to see if there are any signs of fossils.
Right. just as we do on Earth. It's unlikely that there'd be anything that large, but it's an essential step.
Yes.
Once that's been done, the sample is crushed into a fine powder.
Why is that? Doesn't that destroy everything?
Well, luckily, no. And in the next stage of the analysis, the sample has to be exposed to heat and then run through a mass spectrometer.
We'll need to explain that this is an instrument used to measure the weight and concentration of atoms and molecules.
Yes. This level of analysis is necessary to search for microscopic signs of life, much smaller than fossils, such as microbes.
So once all this has been done and the results sent back to Earth, what happens next? Can they do anything with the results?
Yes. They can compare them with data from similar studies done on large bodies of water or desert soils from Earth.
Fascinating. Let's make a start on our presentation slides, shall we?
That is the end of Part 3. You now have 30 seconds to check your answers to Part 3.